Hi geometry students. In this lesson we're going to revisit a topic that we've covered before in Investigation 1. We're going to talk a little bit more about the Pythagorean Theorem. Now you remember the Pythagorean Theorem was a squared plus b squared equals c squared, and it only applies to right triangles. We have these right triangles in front of us in the page. And when talking about a squared, b squared, and c squared, those letters refer to something specific, and you have to keep that in mind when you're using the Pythagorean Theorem. This is the number one pitfall students fall into as they're working these types of problems. A and B are the legs of the triangle, the sides that are touching the 90-degree angle. C is the hypotenuse, the long side, and you have to make sure that C is on the side of the equation where it's by itself. A and B are on the other side. All right, let's go ahead and work some of these problems. We need to find the hypotenuse of this triangle, and then we need to identify whether the lengths form a Pythagorean triple. Pythagorean triple is where the side lengths are all whole numbers that are not zero. So it can't be a fraction or something that needs to be solved. Usually with Pythagorean theorem, if we don't have a Pythagorean triple, if we don't have a whole number, we have an irrational number that we have to solve with a square root sign. We're going to keep all of those in their exact form and not punch the square root into a calculator for this lesson. You also have to be able to figure out what those square roots are without using a calculator. Now, some of them, like letter E, you're going to have to use a calculator, but you have to know how to do it without a calculator as well. All right, let's get started. For our first one, what we're going to do is set up our Pythagorean theorem equation. 400, that's 20 squared, plus 441, that's 21 squared, equals c squared. Okay, I can simplify that by adding 400 and 441 together. I get 841 equals c squared. And the question is, does 841 have a perfect square root? And the answer is yes. 841 is 29 squared, so the answer to our first question is 29. And yes, it is a Pythagorean triple, because it is a whole number. I can make that 20, 21, and 29 are a Pythagorean triple. All right, letter B. Find the value of P in the triangle. Here again, I'm going to do the same sort of thing, but look at how this setup is a little bit different. Notice that because P is a leg and not the hypotenuse, it doesn't go on a side by itself like it did in the previous one. So it's going to be 1600 plus P squared. 40 squared plus p squared equals 41 squared. You may already recognize what's going to happen here. I have to subtract 1600 from both sides, so I get p squared equals 81. Another perfect square. 9 squared is 81. So yes, 9, 40, and 41 form a Pythagorean triple. Next, we have one that's not going to be a Pythagorean triple. Find the value of s in the triangle at the right. Give your answer in simplified radical form. Simplified radical form means you're pulling anything that's squared out of the radical and just taking the square root of it. So if you have like 4 as one of your factors under the radical, you're going to square root it, turn it to 2, and put it out in front of the radical. All right, let's take a look at how this one works. The setup is the same. 36 is 6 squared. 196 is 14 squared. I do a squared plus b squared equals c squared. In this case, it's s squared. I'm going to add those numbers together. 36 plus 196 is 232. That is not a perfect square, but it is divisible by 4. So I'm going to do 4, the square root of 4 times the square root of 58. The square root of 232 is the square root of 4 times the square root of 58, but I'm not going to leave it as 4. I'm not going to leave it as a square root of 4. I'm going to change the square root of 4 to 2. So it's going to be 2 times the square root of 58. Let's just make sure that we answered this one correctly. Here, I got the previous one. And then also, let's find where the answer here. There it was. Okay. Yes, 2 times the square root of 58. Letter D. Find the value of x in the triangle at the right. This is going to be the same sort of problem as letter B, except this time it's not going to come out to a perfect whole number. So notice that I know a leg, or my variable is one of the legs, not the hypotenuse. I know the hypotenuse. So this one's going to look like this. A squared plus b squared equals c squared. 4, which is 2 squared, plus y squared equals 20 squared, which is 400. Subtract 4 from both sides. And then this problem, these problems sort of excel at giving you difficult, perfect, simplified radicals to find. So what is 396 divisible by? You may not know this. You'd probably have to do some work to figure this out, but 396 is divisible by 36. It's 36 times 11. And then if it's 36 times 11, I could say that 396 is the square root of 396 is the square root of 36 times the square root of 11. And then I can simplify the square root of 36, and this becomes 6 times the square root of 11. Letter E is going to be a multiple step problem here. We have the ratio of TV's width to its height is 16 to 9. If its width is 32 inches, what is the length of its diagonal? Now, all of the other problems we were given two sides of a triangle and had to find the third side. Here we're given one side, a ratio that lets us find the other side, and then we're asked to find the diagonal. So in order to figure this one out, we're going to start with the logical place to begin. Let's figure out what that other side is. Okay, so if I know that one side is 32 and the ratio of length to height is 16 to 9, then I can set up a proportion. 16 to 9 equals 32 to whatever h is. Right? Then I'm going to solve this by cross multiplying. When I cross multiply this, and it's not easy to cross multiply with fractions set up this way, but you see 16 times h equals 9 times 32. And when I simplify that, I find that h equals 9 times 32 over 16. Well, wait a second, 32 over 16 is just 2. So this is just 9 times 2, which is 18. The height of this TV is 18. And now I know the width and the height, so it's easy to find the diagonal. Although we'll be working with some pretty big numbers here. The 32 squared, that's the width. 18 squared is the height. That's going to give me the diagonal squared by the Pythagorean Theorem. If I simplify that, I get 1024 plus 324 equals c squared. So c is going to be the square root of 1384, or 2 times the square root of 337. The way I got that, 1,348 is divisible by 4. When you divide it by 4, you find that it's 4 times 337. And then I have to take the square root of 4 times the square root of 337. Square root of 4 evaluates to 2. So the exact answer is 2 times the square root of 337. All right, now you know how to solve Pythagorean Theorem problems. Go ahead and get started on numbers 1 through 30.